a pretty smart guy by the name of Pascal figured out a pattern quite a while ago, and he built it into something called Pascal's triangle. And what this represents is a quick way to do crazy looking binomial expansions. So here's what I mean. A plus b to the sixth power, you would think this is like a nightmare. It would take pages and pages. But if you know what Pascal's triangle is and how to use it, this becomes very simple. So what I want to do is first explain the pattern in these numbers in this triangle. You'll notice if you look at it, if you take any two numbers that are neighboring, add them up, that gives you the number below it. Okay? And that continues forever. So it doesn't matter really how big this exponent is. I'm not going to give you something crazy, but you could, in principle, expand out a plus b to the 10th power, right? It would just be a couple more rows on this triangle. Now here's how we use the rows. You'll notice along the side, I've labeled this 0th, 1st, 2nd, 3rd, 4th, etc. What that refers to is the power. So if I have a plus b to the 0th power, that's just going to be 1, right? Anything to the 0th power is 1. If I have a plus b to the 1th power, that's just a plus b. Hey, look at that. It matches the coefficients, 1a plus 1b. If I try this, a plus b, and I'm going to run out of room here, a plus b squared, that's a squared plus 2ab plus b squared. Now that one you probably already knew, or you could just figure it out from foiling these two. A plus b squared is really not that bad. But look at that. It's 1a, 2ab, and then 1b squared. And that matches these coefficients in this row right here. Now, if you happen to know what comes next, the next one would be, well, a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Go ahead and expand it out. You'll get exactly what's predicted by this third row, or the third power of Pascal's triangle, and so on and so on and so on. Now, what this problem is asking for, let's zip ahead to what we're doing right here. This is the fourth term, orange, I think that'll look nice, the fourth term of a plus b to the sixth. So what you do to answer this is you go to the sixth row of the triangle and the fourth term, which is right here. And this is actually, remember, the coefficients of the fourth term. So that means the fourth term is going to be 20 times something. We can write in the number 20. We know that part. And then we just have to figure out, well, it's a to some power times b to some power. And if you've noticed the pattern so far, the first term over here is always a to some really big power. So it starts out a to the sixth, and there's no b term. It's just b to the 0th power, which is 1. And then you have a to the 5th times b to the 1. Then you have a to the 4th and b squared. And then when you get to the fourth term, this is going to be a cubed, b cubed. All right? So we can quickly, if we have a triangle in front of us, we can quickly find any term of a binomial expansion. Now, what if things are not as simple as just a plus b? Right? And I'll do a quick example here. What if we wanted to give the full expansion of, I was about to write x plus y, but that's really not any different. What if I said 2x minus 3, and I want to raise that to the 4th power? Well, this would take a while, except we know Pascal's triangle now, and I'm going to come in here and grab this fourth row of the triangle. And I'm going to say, well, look at this. This is just going to be 1 times a to the 4th, b to the 0, plus 4 a cubed, b to the 1th, plus, what comes next? 6 times a squared, b squared, plus 4 comes next, and this is a b cubed plus 1 times a to the 0, b to the 4th. Squeeze that one in there. Okay. Now what you have to do is just recognize that we're not really dealing with a and b. What we're really dealing with, this is a, and this number right here is b. So now we just substitute those in. And I'm not going to change color. Let's just write it here. So this becomes a to the 4th. Well, it's not a, it's 2x. So 2x to the 4th. And b to the 0 is just 1. So we forget that. And then next, it's times 4. Remember, a is 2x, and that's to the 3rd power now. And b to the 1th just means times negative 3 to the 1 power. So negative 3. And then you have 6 times not a squared, but 2x squared. And negative 3 is b, and we're going to square that one. And then 4 times 2x, and then times negative 3 cubed. And then our last thing right here at the very end is negative 3 to the 4th power. So hopefully you can see how there's two patterns here. There's the pattern of the exponents. A, the first variable, starts high and goes low. B, the second variable, starts low and goes high. So 6, 5, 4, 3, 2, 1, 0 for A, 0, 1, 2, 3, 4, 5, 6 for B. If you're on the 6th power, if you're on the 4th power, it just starts at 4, right? Same difference. And then the other pattern is the pattern of coefficients. And that's these numbers in the triangle, right? And that tells you whether it's a 4 or a 6 or a 4 and so on. And now all that we would need to do at this point is a little cleanup work. Simplify this down. So instead of 2x raised to the 4th power, I could say, oh, that's just 16x to the 4th. And then this next one, well, yeah, the numbers get kind of big. 4 times 8 times 3, which is 96. I don't know. Double check me on that. Minus negative 96 x cubed. So I'm not saying the numbers don't get big, and they're a little bit of a pain to deal with, but we have calculators for things like this. What this helps you do, as long as you have some handy way to multiply the integers together, is expand out a binomial, or if you need just one particular term, you can quickly find that term.